Hello everyone. In this video, I'm going to talk about gas laws and reviewing some practice problems. First, in another video, I already talked about three parameters of gases: pressure, volume, and temperature. And I said if we know information of these three, we are able to predict behavior or properties of gases. The first and major gas laws in this chapter is the combined gas law. So the combined gas law is going to combine these three parameters. So let me write the relationship between them in combined gas law. P1 V1 over T1 is equal to P2 V2 divided by T2. Here 1 subscript 1 represent initial and 2 represent final conditions. So initial and final conditions. We are going to know what does that mean when we say initial final condition. So let me give it you one example. If I say we are going to change temperature of a gas sample from 2 atmosphere to 5 atmosphere, it means the first one is initial pressure, the second one is going to be final pressure. So if we have like this, we are going to change volume of a gas sample from 2.1 ml to 3.7 ml, for example. So here in this example, the first volume is going to be the initial volume and the second volume is going to be the final volume. So if I'm going to consider that one for solving our problem, this one is going to be V1 and the second one is going to be V2. They are something we should know about that one. Right now, I'm going to back and derive some gas laws based on this major law. Let me highlight that one. So we are going to solve some problems and we are going to derive some equations based on the combined gas law. The first gas law that I can derive here, when the problem says we are going to solve our problems at constant temperature. Constant temperature. We are going to know what does that mean when we say constant temperature. When we say constant temperature, it means there is no temperature change. It means T1 is equal to T2. So there is no temperature change. So if our problem says at constant temperature, it means T1 is equal to T2. I'm going to derive a new equation here. Let me derive this equation here. I'm going to write P1 V1 over T1 is equal to P2 V2 over T2. It says T1 is equal to T2. So it means you can exclude temperature from the equation because both are same. So you can remove temperature from the equation. If you remove that one, the only thing remains is P1 V1 is equal to P2 V2. So right now, let me remove temperature. So the only thing it remains here is P1 is equal P2. Here, this new equation is applied whenever our problem says at constant temperature, at constant temperature. And we call this one, this equation, or this form of combined gas law, we call that Boyle's law. We call that Boyle's law. Let me write that one. Boyle's law. How about this one? If we say we are going to study our gases at constant pressure, at constant pressure. What does that mean, constant pressure? It means there is no pressure change. P1 is equal to P2. Right now, let me rewrite the equation. P1 over P1 V1 over T1 is equal to P2 V2 over T2. And we say pressure is the constant. So you can cross the pressure here. So let me cross that one. So I'm going to remove the pressure from this equation. So the only thing it remains is V1 is equal to V2. So let me write that one in a better form. V1 and here I'm going to keep that one V2. So this is a new equation you can derive here. V1 over T1 is equal to V2 over T2. Whenever our problem mentions we have constant pressure, if it says we have constant pressure. So you can easily derive that one. Right now, we are going to call that one Charles's law. So we are going to call that one Charles's law. How about if we have at constant volume? At constant volume, it means V1 is equal V2. So I'm sure you can rewrite this equation one more time. P1 V1 over T1 is equal to P2 V2 over T2. P2 V2 over T2. And right now we are going to remove volume from the equation because there is no change for volume. When we have like this, let me remove that one here, and we have like this form. Let me rewrite that one to have better form of writing. P1 over T1, P2 over T2. So at constant volume, we are going to have like this form of equation. This form of equation, it leads us to a new gas law, relationship between pressure and temperature only. We call that one Gay-Lussac's law. So if we are going to solve our problems, it depends on our problem. It depends on the conditions reported, constant temperature, constant pressure, or constant volume. We may use one of these three equations. If it doesn't mention any of these three parameters are constant, we are going to keep in mind and solve our problem based on the combined gas law. Let me give it you one example here. Question says at constant temperature, we change volume of a gas sample from 5 liter to 7.8 liter. Assume the initial pressure is 3.9 atmosphere. Calculate the final pressure in atmosphere. As you see here, in this example, our problem focus on constant temperature. Constant temperature. So let me write the equation here. I'm going to write P1 V1 over T1 is equal to P2 V2 over T2. So it says constant temperature. It means we can remove temperature from our equations. So I'm going to write like this. So our equation is P1 V1 is equal to P2 V2. And then I need to find the information for this equation. It says we change volume of a gas sample from 5 liter to 7.8 liters. So I'm gonna write that one. This is the V1 and this one is V2. So I'm gonna write that one. V1 5.0 and V2 is 7.8 liters. Assume the initial pressure is So we are going to talk about initial pressure. Initial pressure means 3.9 atmosphere. So I'm gonna write that one. This is the P1. So it says P1 3.9 atmosphere. And it says calculate the final pressure. And unit for final pressure, it says in atmosphere. So I'm gonna rewrite that one, P2, and we need to calculate that. So P1 V1 is equal to P2 V2. We are going to solve our problems for P2. We are going to solve our problems for P2. Let me highlight P2. We are going to isolate P2 in this equation. I am going to divide both sides by V2. I'm gonna cancel out V2. That is why I divided both sides by V2. So question has this equation, rearrange equation, P1 V1 over V2. I'm gonna solve our problems. So P1 is 3.9. Let me write atmosphere times V1 5.0 liter divided by 7.8 liter. So I'm gonna cancel out the units. So I wanted to show you if we are going to plug in the equation how to solve your problems. You don't need, it's not necessary for you guys to use the units for our problems. At the end, you may report that one. 3.9 times 5.0 divided by 7.8. So the answer is 2.5 and the unit is atmosphere. So right now I'm going to double check the suffix. 2 suffix, 2 suffix, 2 suffix. So I'm going to report by fewest suffix. It means 2. So the final answer for this problem, it says 2 suffix. So 2.5 atmosphere is going to be the correct answer for this one. And you are going to double check to see it makes sense or not. So volume is going to increases. So volume from 5.0 liter is going to increase to 7.8 liters. When volume increases, pressure decreases. So pressure must be less than 3.9. So as you see here, pressure decreases and we have 2.5. So this is the meaning of Boyle's law in case you are going to have another point of view when you are going to solve your problems. Right now, I'm going to talk about the one law. It makes sense to call that one Avogadro's law. Avogadro's law is going to give us relationship between moles and volume. So we know the Avogadro based on his achievement for moles, Avogadro's number. For volume, always we use this notation, V. Whenever we are going to work with moles, we report moles by N. So N represents mole. So I'm going to write that one. N represents mole. The Avogadro's law has this equation. V1 over M1 is equal to V2 over N2. So whenever we have the number of moles of gases, we are able to calculate volume of gases as well. So in this law, if N increases, volume increases as well, because when you have more amount of your gas, absolutely you have more volume as well. So this law is super easy. We are going to plug in the equation. So for example, it says if we have if 2.5 moles of oxygen gas occupy 3.8 liter, what volume of oxygen gas has 9.6 moles. Let me write that one in liter. So we are going to work on simple calculation. So question says, if 2.5 moles of oxygen gas occupy 3.8 liters, what volume in liter of oxygen gas has 9.6 moles? So I'm gonna write that one. This is the mole, and this is the volume related to these moles, V. Question says, what is the volume? Question mark for volume. And if we have 9.6 moles, N. So it's easy. You can consider that one N1, V1, and this one is V2, N2. Or you can say the second one or first one. It doesn't matter at all because these two are related to each other. These two are related to each other. We can consider for one type of condition and these two for the second type of conditions. I'm gonna plug in the equation. Let me plug in the equation. V1 over M1 V2 over N2. Before solving our problems, I'm gonna say that one because N increases, look, the number of moles increases from 2.5 is going to be 9.6. If N increases, volume must be increased. So we are going to talk about a number more greater than 3.8. Let's see this equation and our calculation approve that one or not. So I'm gonna find for V2. So I'm gonna find for V2. Let me highlight V2 here. So I need to rearrange this equation to get the V2. I need to multiple both side by N2. N2 and N2 cancel out. So V2 is equal to V1 over M1 times N2. So let me plug in the equation. V1, 3.8 liter, N2, it is 9.6 moles, over N1, 2.5 moles. So moles and moles cancel out, and we are going to have liter as final answer. So I'm gonna report my answer. Just double check. We have two suffix for each one. So we are going to report our final answer by two suffix. So the answer is, let me calculate that, 3.8 times 9.6 divided by 2.5. So the answer is 14.59. So I'm gonna report by two suffix. So I'm gonna keep two suffix here. So I'm gonna say 15 liter because this digit is 5. We need to round off. So the final answer is 15. As we predicted that we are going to have a number greater than our first or initial condition 3.8, and it does make sense. Another law I'm going to talk about that is Dalton's law. It is going to call Dalton's law. For the Dalton's law, we are going to have this basic law. Total pressure of a mixture is a summation of partial pressures or pressure of the components. So assume that we have a mixture, our mixture composed of three gases. First gas has 1.0 atmosphere, the second gas has 3.9 atmosphere, and the third gas, it has 2.3 atmosphere. So let me write that one as atmosphere to make sure when you are going to calculate, you have the same units for each one. So if question is, what is the total pressure for this mixture? So I'm going to ask you to think about that. If we have a mixture of, for example, three gases, we are going to know what is the total pressure of the mixture. It means we need to add pressure of each component to each other. So I'm going to write that one. Total pressure is summation of components pressure. We call them partial pressures. So here we say 1.0, 3.9, and 2.3 atmosphere. So if I add these numbers, let me calculate that 2, 3, 5, 6, 7.2 atmosphere. So Sigfig rules, because we have additions here, let me write like this one. When we have addition, rule for addition is fewest decimal places. Fewest decimal places. One decimal, one decimal, one decimal. So we are going to have one decimal like this. So let me give it you another example to make sure you understood this one. So assume that we have a mixture of gases. So assume that we have four gases here. Let me write like this. 1, 2, 3, 4. First one has 2.8 atmosphere. Second one has 3.9 atmosphere. We don't have any idea about the fourth one, third one, and fourth one is 1.6 atmosphere. Question says if total pressure is 12.8 atmosphere, calculate pressure of component C. So we are going to work on this problem. We have total pressure. Total pressure is given 12.8 atmosphere. So, and we have four components here. We do have four components here. A, B, C, and D. So I'm gonna write that one. Total pressure is summation of pressure of each component. So 12.8 is equal to, for this one, 2.8 plus 3.9. We are going to calculate this, and for last one we are going to have 1.6. If you solve this problem, I'm sure you can easily get that one. You are able to find the pressure of component C. Component C. So at this example, let me write that one. The correct answer is going to be like 4.5. Like 4.5. So it's not complicated law. You just need to remember that if we have a mixture of gases, the summation of the components, summation of parts of this mixture are going to make total pressure for the mixture like this one. Please understand we have some definition for partial pressure and so on, but in this video I just focus on only the Dalton's law. And finally, the last law I'm going to review that one here. If we are going to combine our knowledge regarding pressure, volume, temperature, and mole, if we are going to combine them, we are going to conclude to this law. We call that ideal gas law. Ideal gas law. Ideal gas law, it means we assume that our gases behave ideally. They are going to be in specific conditions. For PV is equal nRT, we are going to have only one condition. So we don't have two conditions, initial or final conditions. Please understand, for this law, we have pressure, volume, moles, and temperature. This is the first time mole is added to these three parameters. R, as we reviewed already in another video, is a universal gas constant. is a universal gas constant, and this is the number always given to you. This one has this unit: atmosphere, liter, mole, and Kelvin. So R is a universal gas constant. It's going to be provided for your exams and quizzes. So we are going to plug in this equation. As you see here, we have this unit for pressure. So it means this is a must. Whenever we are going to use this ideal gas law, we need to have our pressure in atmosphere. Based on this law, R is in liter. It means this is a must. Volume must be reported in liter. It means whenever I have another unit for volume, I need to convert that one to liter. If I have another unit for pressure, I have to convert that one to atmosphere. Moles always is mole. So if we don't have moles, we need to convert to moles. If you have grams, you need to convert to moles. And for temperature, we already talked about that one. Temperature must be in Kelvin in this chapter. There is no exception for temperature. Always must be in Kelvin. So let me solve one problem here. Let me solve one problem here. What is the volume in liter of, let me write that one like the pressure because it's easy to calculate in this first example of 3.9 grams of nitrogen gas when it occupies 6 point, let me write like this, 681 milliliter at 25.0 degrees Celsius. So question gives us also this information. R is 0.0821 atmosphere, liter or mole, Kelvin. So question says what is the pressure in atmosphere of 3.9 grams of nitrogen gas when it occupies 681 milliliter at 25 degrees Celsius. First, let me solve this problem by writing the short form of this equation. What does that mean, short form? Question says what is the pressure in atmosphere? So I'm gonna write that one. Pressure question mark in atmosphere. If we have 3.9 grams of nitrogen gas, guys, this is the mass. This is not moles. So let me write that one. Mass is 3.9 grams nitrogen when it occupies 681 ml. So we are talking about volume. So I'm going to write that one, volume 681 ml and 25 degrees Celsius. So this is the temperature, 25 degrees Celsius. So I'm going to highlight the information that we have. Pressure, question mark. We have mass, we have volume, and we have temperature. So all of them are reported once. We don't have any changes in temperature, in volume, in pressure. So it means we have to report this equation, ideal gas law. PV is equal nRT. When we are going to solve this problem, we need to know the R. So it looks R already given. So it means we are able to solve this problem. When I'm gonna solve this problem, at the beginning, I'm going to recommend you, please do like me. I need to check the units. Pressure is atmosphere, so I'm going to calculate in atmosphere. Volume liter, it says 681 ml. So I'm going to convert liter to milliliter to liter. How to do that? So whenever, let me write that one here on this side. Whenever you are going to convert milliliter to liter, you just need to multiply by 10 to negative 3. I'm sure you know the meaning of the milli as a prefix. It means 1,000th. But whenever you are going to convert milliliter to liter, you don't need to divide by 1,000. You don't need to do any conversion factors. You just need to multiply 10 to negative 3 and write that one liter. So let me remove ml here. So whenever you have ml, multiple 10 to negative 3. So you don't need to be worried regarding the significant change. So always multiple 10 to negative 3. And whenever we have temperature, I'm going to add to 273. 273. So I'm going to get that one to 98K. To 98K. So right now I have volume, temperature, and R. So let me check mark. Volume, temperature, R. To find P, I need to have N. But N, moles, is not reported here. It says grams. So you need to convert grams to moles. How to convert grams to moles? You need to use one conversions. What does that mean? It means you should say if we have 3.9 grams nitrogen multiplied by grams nitrogen, I'm going to convert that one to moles nitrogen. So how to get that one? So 1 mole nitrogen, you know that molar mass of nitrogen, diatomic nitrogen, N2. It means 28.02. Please look at the periodic table. Nitrogen has 14.01. So if we are going to solve our problem, we need to have moles of nitrogen. Moles of nitrogen. If we don't convert to moles of nitrogen, it cannot be solved correctly. So let me calculate that one. So whenever you have grams, you need to convert to moles. How to convert to moles? By using molar masses. So I'm gonna calculate to keep the correct answer for this one. 3.9 divided by 28.02. So the correct answer is, let me write like this by another color to make sure it's easy for you to keep track the numbers. 1.3918 moles nitrogen. So right now I'm going to plug in the equation. PV is equal to nRT, and we need to keep pressure and rearrange the equation. I need to divide both sides by volume. So volume and volume cancel out. So pressure is nRT over V. nRT over V. Right now, I'm gonna plug in the equation. So N 0.13918 times R 0.0821 times T 298 divided by volume, parentheses 681 times 10 to negative 3. One thing I ask you to please pay attention when you are going to calculate for the problems like this, we are going to apply the sigfig rules. So we need to count sigfig rules here. When you are going to count sigfig rules, please understand, we are going to consider this number 3.9 two sigfigs. It means I need to keep two sigfigs here. So whenever you are going to address sigfigs, so two sigfigs here, three sigfigs here, absolutely three sigfigs here, three sigfigs here. So our number, it must be reported by two suffix because this number, it has two suffix. So right now, I'm gonna report that one. Let me see. So it looks our pressure is 5.0 and times to 1, 2, 3, 4, 5, 6. So 5.0 times 10 to negative 6. So let me write like this. Unit is atmosphere. So please double check to make sure you have the correct answer like me. Alright guys, let me correct that one to make sure you have the correct answer like me. 5.0 atmosphere is going to be the correct answer for this question. So I'm gonna make sure you have the correct answer like me right now. So this is the correct answer I calculated and I got this number. So I'm gonna write the equations here. We work with the Avogadro's law. V1 over N1 is equal to V2 over N2. We work on Boy's law. At that time, I said P1 V1 or is equal to P2 V2. Then we work on C law. So I said for Charles' law, we are going to have V1 over T1 is equal to V2 over T2. Then I talk about Dalton's law, and I said for Dalton's law, we are going to have total pressure, it's same as summation of pressure of components. Then we talk about another law, G law, Guy-Lussac law. So I said that relationship between the pressure and temperature, P1 over T1, P2 over T2. We talk about two main laws. One, the combined gas law. It means we need to combine three parameters. We call that P1, V1 over T1 is equal to P2, V2 over T2. And finally, ideal gas law. This is the I law. So for the ideal gas law, we have PV is equal nRT and R is universal gas constant. So for R, we may have another numbers as well, but this number is in atmosphere times liter over mole K. So as you see here, the equations A law, B law, C law, and the combined gas law are going to apply with G law. They are going to apply for the final gas law, ideal gas law. So we use these laws, combine them, we derive them from the combined gas law, and Avogadro's law help us to make this law. But in this law, we don't have any changes of parameters. This is the simplest law that we have. We do have some more laws that we don't cover in this video and it's not on our class textbook. Last thing I'm going to talk about that, assume that we are going to combine gas laws and stoichiometry. We call that gas stoichiometry. So if we are going to work on the gas stoichiometric problem, assume that we have a question like this. What volume in liter of oxygen gas are produced if 3 point, let me give you like this, I already talked about 3, so 5.8 grams KClO3 are decomposed at 9.6 atmosphere and 31 degrees Celsius. KClO3, it gives us KCl and O2. This is a solid, this is a gas, and this information already given to us. Alright guys, I ask you to first understand the problem. Question says what volume in liter of oxygen gas? We are going to talk about oxygen gas. So what volume in liter of oxygen gas? I'm gonna write that one. What volume in liter for oxygen gas are produced if we have 5.8 grams of KClO3. KClO3. So we are talking about this one. 5.8 grams of KClO3. So mass of KClO3, 5.8 grams, are decomposed at 9.6 atmosphere and 31 degrees Celsius. So we are going to talk about these conditions. 9.6 atmosphere, it means our pressure is 9.6 atmosphere, and it says temperature is 31 degrees Celsius. So temperature is 31 degrees Celsius. Question also gave us R as well. So one thing we should know when we are going to solve our problems for gases, so PV is equal nRT. Question says what volume? I'm gonna solve for volume. I need to keep volume here and divide both sides by pressure. Pressure and pressure cancel out. So volume is nRT over P. This equation is only for gas, only for gases, ideal gas law. In this stoichiometry problems, in the equation, the only gas is oxygen. The only gas is oxygen. It means we can solve this equation only for oxygen. Volume of oxygen, moles of oxygen, temperature of oxygen, and pressure of oxygen must be considered to solve this problem. It says oxygen, but we do have information of KClO3, another compound, and is not gas, is a solid. So based on this equation, we are able to convert potassium chlorate to oxygen. So that is why we call that stoichiometric problems. In stoichiometric problems, you are able to convert one substance to another one. First step to solve our problems, we need to have a balanced equation. If you don't have balanced equation, you must balance that one. So let me balance this equation first. I'm gonna write 2 potassium chlorate, 2 potassium chloride, and 3 oxygen. Right now I have a balanced equation. I need to know this information: pressure, temperature, R, and N to solve my problem. By a good approximate, we can consider that 9.6 atmosphere is the pressure of oxygen. So we just need to write pressure is 9.6 atmosphere. T is going to be 31 degrees Celsius. So let me add to 273 to make sure this number is going to be in K. So I'm going to write 304 for temperature. R is 0.0821. I'm going to write that one. So N moles of oxygen. I don't have moles of oxygen. Please look here. I used T to solve my problem. I wrote here pressure. I just plug in the equation. I need to find V. V is here. And R, I already used that one, is here. I already used all of this information except mass of potassium chloride. So I need to find relationship between mass of potassium chloride and moles of oxygen. So it means the key in this equation, I need to convert mass of potassium chloride to moles of oxygen. Then when I have moles of oxygen, I plug in here and solve my problem. How to convert that one? I need to set up a stoichiometry calculation. How to set it up? I'm gonna write here, and I may ask you to pause the video and see, do you remember that one from the stoichiometric chapter? We solve on problems similar to this one or not? I'm going to write the problem here, 5.8 grams KClO3 multiplied by, I'm gonna write grams KClO3, and I need to convert it to moles KClO3 because in this equation we have relationship between moles of these two substances. So I need to convert grams to mole. 1 mole KClO3, you need to calculate molar mass. So we need to calculate that one 122.55. Let me use this one. Grams and grams cancel out. So the next, I need to convert moles KClO3 to moles oxygen. This number for oxygen is 3, and this number for oxygen is 2. Moles KClO3 and moles KClO3 cancel out. So this is one example of stoichiometric calculation. The only unit remains is moles of oxygen. So you just need to calculate to get the correct answer. But please remember that one. First, you need to balance the chemical equation to find relationship between each substance, like these 2 and 3. And then you need to calculate molar mass of your substance to convert it to mole. So the answer is 0.0709 moles, for example, here. I need to keep only 2 sigfix because 5.8 has 2 sigfix. So the 0 at the beginning is not sigfix, so I'm going to consider only 2 sigfix here. So I'm going to keep whole number here because at the end I can balance, I can apply the sigfix rules. So in this problem, I need to keep only 2 sigfix because of 5.8. So if you calculate that one, if you calculate, you may get a number like this one. Hopefully, you are able to get same number like me here. So the volume is going to be, let me write here, volume is 0.18 liter. So one more time, if you have a stoichiometry calculation, first you need to know, you need to convert mass of another substance to moles of your gas substance. If you do that, you have N for your gas. You also have R, you have T and P, and you can easily solve the problems. So again, this part that you need to solve your problem, we call that stoichiometry. So when you combine the stoichiometry with the gas law, we call that gas stoichiometry. Hope these examples and reviewing the gas laws help you to get a better understanding regarding this chapter. Thank you for watching this video as always.